we had this warm-up. We had the speed a car was traveling. We had some data for that. And we had how far that car needed in distance and feet in order to stop, in order to make sure it's stopping safely. And so you had a 10, 27, all that data. So on you had a scatter plot. You plotted your points. You graphed your data. Then we took our ruler. We drew our line of best fit. What is the trend that we saw with this? Or should we call that positive? We have a positive trend or a positive correlation. So as the speed increases, the stopping distance increases. So the faster you're going, the farther distance you'll need in order to stop your car. So we have our line of best fit. Yesterday, we talked about creating once we drew that line of best fit, we practiced finding the line of best fit. So in order to find the line of best fit, you need to choose 2 points that your line seems to pass through that we can use to find the equation of that line. So someone give me 2 points that their line passed through, or 2 data points. That seems like Wyatt.
1544 and 2063.
So your line passed through 1544 and 2063?
Yeah.
Okay. So we're going to use these points to help us find the equation of our line of best fit. And your line, of course, might be different. It might pass through different points. But the idea is just to get an estimate. So 1544 and 2063, were those the 2 points? Yes, okay. So once again, in order to find the equation of the line, we first need to find the slope of the line, because we need to find the slope and the y-intercept. So we're going to take y2 minus, that's y1. y2 minus y1 over x2 minus x1. So 63 minus 44, that gives us, what is that, 19? 20 minus 5, or 15 is 5. So 19 over 5. Once again, with these lines of best fit, we're probably going to get uglier numbers. We're not going to get perfect numbers because we're using data. It's real life. Not everything in real life is perfect. So we'll have to figure out what this is. So 19 divided by 5. My calculator turns on.
That looks like a 7. Looks like a 7 with a curve.
That's 3.8. So 3.8 is the slope of our line. So now that we have the slope, we can use this to find the y-intercept. So once again, we have y equals m, which our m is our slope, so we learned m was 3.8, x plus b. In order to solve for b, that's connected. Okay. In order to solve for b, I need to figure out what that b is, or I can't have that y and that x in my equation. So what can I do in order to solve for b? I can use one of my coordinates. I'll use 1544. That means y is 44 times 3 equals 3.8 times my x, which is 15, plus b. I'm going to put this a little bit lower because I'm running out of room up there. So I have 44 plus 3.8, 15. I know we're going into the other question, but we'll get to that. So in order to solve this, we want to first multiply that slope by your x-coordinate. So 3.8 times 15. Once again, you'll probably have to use a calculator because we're going to get some uglier numbers. That gives us 57. In order to find b, we can subtract 57. And then 44 minus 57, that leaves us with negative 13 equals b. So our final equation of our line of best fit is y equals 3.8x minus 13. Now, once again, this line of best fit, this is an estimation. It's not going to be perfect. It's not going to give you the most accurate answer ever. We used it by estimating with our eyes and drawing a rule, just picking 2 points and figuring out the math from it. So it's not going to be perfect, but it can help us figure out future predictions. They can help us figure out future events. So let's say that we're driving a car and it's going at a speed of 60 miles an hour. So 60 wasn't one of our data points. 60 wasn't on our graph. We want to use this line of best fit to estimate how far of a distance we need to stop if we're driving at 60 miles an hour. So thinking back to our situation, speed, so 60 miles an hour is our x. We're looking for the stopping distance, so we're looking for y. So we're going to take that line of best fit, the equation we had, the y equals 3.8x minus 13, and we are going to plug 60 in for our x, plug 60 in for our speed. That equals y equals 3.8 times 60 minus 13. So again, 3.8 times 60, we'll want to calculate that. I think so. Yep. That's 228 minus 13 is equal to y. So y equals 215 feet would be our answer. So once we plot this data, we can find 2 points of our line, create the equation of our line, and use it to predict future events. Yes, Destiny?
Okay, so you 3.8 times 60. After you get the answer to that, you minus 13. Okay.
And that would be equal to your... Do we have questions over the steps we took to get this? All right. So this is basically what your entire quiz will be. You'll just have one problem. You'll have some data. You'll need to plot it. You'll need to find the equation that line of best fit. Then you'll use that line of best fit to answer one question. Use it to predict some future. That's basically, it's just be one problem, and that's your whole quiz for Friday.
And we shall predict the future.
Not yet. We'll take a little bit of practicing. All right. So we have some data here. So this is number of hours slept before, or 2 nights before running a 5K. And so here's the amount of sleep this person or a runner gets before a 5K, and here's their time in minutes they did on that 5K. So we want to see is there a relationship between how much sleep you get before running the 5K and how much or how well you do on that 5K. So plot this data, find your line of best fit, pick 2 points, and find the equation, and then we'll use it to predict in the future. So see if you can find the line of best fit. Okay, so we should have been able to plot our point, or plot our graph. We should have been able to draw line of best fit. By now, hopefully you have been able to find your slope. What were 2 points that someone's line passed through? What were 2 points someone used? Wyatt, what did you use?
9 and 21.3, 10 and 20.
9 and 21.3, and then 10 and 21. So once again, these points might be different from your points. These points might be different from your points. And so your slope might be just a little bit different. It should be close, but it might be a little bit different, and that's okay. So if we were to solve this, we would do y2 minus y1 over x2 minus x1.
0.3 minus 1.
So that's negative 0.3 over 1, which is just negative 0.3. So that's our slope. Once again, once you find your slope, you need to find the y-intercept as well. So y equals our slope of negative 0.3 x plus b. In order to solve for b, we have to plug in a point for x and y. So I'm going to take 10, 21, just because I feel like they'll be easier numbers. So 21 equals negative 0.3 times 10 plus b. Once again, your numbers might be different. That's okay. Negative 0.3 times 10. Negative 0.3 times 10 should be negative 3. So 21 equals negative 3 plus b. In order to solve, I can just add 3. And so 24 equals b. That should be my b. So my final equation of my line of best fit is y equals negative 0.3x plus 24. Once again, your line of equation or your line of estimate might be different, and that's okay. Are we okay on the steps with this? Let me check. All right. So once again, we want to use this to predict the future. We want to use this to make some estimations. So we want to estimate the runner's time if he slept for 4 hours the night before the race. So this runner only got 4 hours of sleep the night before the race, or two nights before the race. So once again, hours of sleep, that is our x. Time is our y. So we want to figure out what his time is. So we want to solve for y if we have 4 in for our x. Plus 24. So we're going to have to do negative 0.3 times 4 to solve for y. Negative 0.3 times 4, that should be negative 1.2 plus 24. So y equals 24 plus negative 1.2 should be 22.8, 22.6. And 22.6 minutes, that is how long, or that would be the estimated time for this runner after that many hours of sleep. Are we okay with this?
Yes.
So I think one focus or one issue that we're having is we're just having trouble focusing. It's a lot of steps. It's a lot of things to work through, so we just have to stay focused, be able to work through the problems. They're long problems. You don't like the graphing? So one thing we can look at tomorrow is rather than using a graph like this, I can show you how to use a website. And then you can plot it on a website and we can kind of find the line of best fit that way. You don't want to do that? Oh, that's true. I'm sorry. I can show you the website. All right. All right, so we have I'm going to give you one final question that I'm going to try to have you do by the end of the period. So, this question. So, forensic scientists, they can use data from the relationship of the size of someone's feet to the size of their height. They can use this to help determine culprits if they have a footprint. So if an officer finds a footprint, forensic scientists can look at the size of that shoe and they can use some data to determine or predict what the height of that person is. So you have some data here. You have some shoe sizes, which is your x, and you have some height in inches, which is your y. So try to plot this data, see if you can try to find the line of best fit, and if you have enough time, predict what the height of a person with a 9.5 shoe size should be based off of your line of best fit. So it's a lot of stuff. See if you can try to do it before the end of the period.